Hello and welcome to the follow along project, Downhill Jam. We're going to make a little racing game. And more importantly, we're going to play with some object-oriented inheritance and creating some nice clean code and using some patterns that will be extensible and flexible and things that we're going to use quite a lot. So we're going to make a new 2D project just for this little 2D racing game. And this is going to be a 2D URP project. Just, switch things up a little bit, get some experience in the universal render pipeline with 2D graphics. We won't really use many of its features. I have already done that here. So now let's get started. So what game are we making? What is our task? My pitch is this. I love these old arcade racing games. You go to like a Dave & Buster's or whatever, and you're playing those racing games. And there's this particularly satisfying game loop that these racing games have, where you have this countdown timer at the top that's like imposingly ticking down. And then as you go, there are these checkpoints along the way where when you hit a checkpoint, boop, you get more time. So it's not about how fast it takes you to get to the end goal. It's like, you have a bad section, you need to get caught up, and I know it's an interesting game loop. You're sort of playing this series of mini races. So our first step will be to sketch out our game. Here's what I've created for our task list. We are going to work on a top-down 2D car controller in this part 1 of the project, and probably do the camera follow as well. And we'll put in some placeholder art assets. So that's the plan for this video. In the next video, we'll work on the pickups, which is the real object-oriented, sort of the whole point of this, learning outcome-wise. And we'll also work on the timer as well. And then we're going to do a UI system, a much more complicated UI system than we actually need for this project. But the goal is, again, just to demonstrate more uses of these object-oriented inheritance patterns that we can use, that polymorphism. And we'll need some kind of manager to hold on to the game loop. So let's start with the car controller. Here I made a future tasks list of just things that are just not in scope of the video. Car particle effects or spawning dust trails and screech marks, skid marks of the tires when you're drifting and stuff. AI would be important for a game like this. I think other cars having a little speedometer on the heads-up display would be important. And the car controller is not going to be all that good, but it's okay. It'll be good enough for us to play through the game and worry about the code, which is the actual important thing. We're not going to spend that much time really fine-tuning the physics, which is sort of the challenge here. So let's make a new folder for our scripts and let's get started. Should we start with some code or should we start with some placeholder art assets? I think we need some placeholder art assets. I don't think I can get started without a car in front of me. I could use a rectangle, I could use a sprite, but let's get started with some sprites. So I'll make that folder as well, sprites. And in this folder, we are going to use some assets from Kenny, Kenny with an E, wonderful, CC0 public domain assets that we can use. And we have these great tiles that we can use to draw and paint a sort of a 2D racing game that'll look a lot like this. Although in my mind, it's not a closed loop. It's like a start, and then you kind of go for a while and hit a finish. But that's going to be good enough. So let's download those. As you can see, I already have. And we'll extract that zip. As you can see, I already have. And we can take the sprites. So I'm going to make a new folder in my Unity projects. I'll call this Kenny. And we'll throw the license and the link. Let me just open this up. And we'll throw the link and we'll throw the license just in this file, just so later when I'm trying to find the assets and put together my credits and my attribution, they're right there. I'm not going to forget it. And the question is, do we want a sprite sheet? Do we want the single image that we can slice up as a grid? Or do we want these sprites already sliced up into square sections? and it's kind of whatever. Frankly, it's usually a little bit more convenient to work with a sprite sheet instead of a bunch of individual images. But for the sake of this project, since we're not going to be using all of these sprites, we're just going to grab the PNG images. So I will copy those into our project. And one thing we're going to do, we see that we have the tiles, the dirt road, which I think I plan on using. I just want to know how big these tiles are. What's their actual like size in pixels? 128 by 128. Okay. So now back in Unity, we'll import these, and we'll start with a car and all of the cars. And this pixels, if I select any of these sprite assets, I'll get all my import settings. But if I select all of my sprite assets, Control A, then I can edit all of their import settings at once. And I want to set that to 128. So that 1 unit is sort of 1 square of our grid here. And I'm just going to do that for all of the assets that we're getting. We're not really going to, I'm not going to use motorcycles. We'll delete the motorcycles. Objects, probably not going to get to using these, but we'll be ready. We'll have it. And then tiles, and we'll just start with the dirt road ones for now, since that is what I plan on actually using. And maybe some grass. Maybe we want some background. Okay, it's fine. We'll just have to remember to change those import settings if I use any other tiles. So now we have a car, and let's pick a color, yellow. Let's drag a car into our scene. Why am I zoomed out so far? There we go. Great. We're almost done. I'm going to rename this to Car Visuals. Car Visuals. And this is actually not going to be the car object we use. It's going to be a child object. And the reason we're going to do it that way is so that we can, when we rotate the main object, we really want to control where the car rotates around. I want my car looking like it's, fishtailing a little bit as it drifts. So I'm going to rotate it around the front of the car. And if you know more about cars than me, you can tell me what that's equating to in real life. But this is a video game and it's 2D and everything's fake, so whatever. So I'm going to take the car visuals. I'm going to right click and choose Create Empty Parent. If you don't see Create Empty Parent, you're in an older version of Unity. So change your Unity version. But this has the convenience of creating the parent at the exact same position as the child. So now my car visuals is like perfectly at local position 0, 0, 0. It's exactly where the parent is. And if I don't do it that way, and I make the parent over here, and then I drag it in, then I'm off center. But if I use the Create Empty Parent, it's just already perfectly lined up. So I'm going to call the parent car. And we're going to take car visuals and move it back a little bit, down a little bit, so that car is kind of in the front area between the wheels, I guess. And then we're going to have the sprite renderer on the same component. We're going to give it a box collider 2D. So we're sort of setting up our car. And I like this box collider, but it's a little, it's not perfect. So we could do a few things. We could edit it to sort of shrink it down a little bit. Just pull it in a little bit. That could feel pretty nice, but I don't want to clip that front corner. So another thing we could do is, instead of a box collider 2D, we could use a polygon collider 2D. And you can see here it tried to sort of match the shape of the car, and it didn't do a very good job matching the sort of that rounded corner. So we could go manually fix that up, but I'm just going to throw a box collider on here and change its size to be just a little bit smaller. Sure, whatever. And then on the parent object, we will add a rigid body 2D, because we're going to use physics to control this car. And we'll remember to change the gravity scale to 0, because if we don't, our game's going to begin and the car's going to fall off the bottom of the screen. And that's not how cars work. Top-down game. Gravity scale 0. Great. Now we're ready to write some code. Now we've got our car set up and we're ready to control the car. So we'll make a scripts folder, and inside of it, we're going to create two scripts. We're going to create a input script and the car controller script. So it's going to be car input and car controller. All right, we can open those up in JetBrains Writer. Don't want to minimize that. I want to do that. Great. So the car controller is a little more complicated, and we're going to move pretty quickly through it because I don't actually care about teaching us how to do all the physics stuff of a car controller. But I am going to give you a good enough for this game to be, I hope, enjoyable car controller and no more. So that's as far as we're going to get. So to start with, we're going to get a reference to the rigid body. Even not knowing anything about how the car controller is going to work, I know I'm just going to be adding forces to the rigid body. So let's do that. Let's make a variable to hold on to our rigid body, and let's do a get component call in awake. So we'll set that variable equal to the rigid body component attached to the same game object that the car controller is attached to. So back in Unity, after we compile, we can add our car controller, and we can go ahead and also add our car input script. In our car controller, we are going to control our car. We're going to be applying forces to the rigid body, and we want to be doing that in a fixed update loop. If we're doing things with physics, we want to be using fixed update. We don't want to be using the normal update loop because the normal update loop is gonna run more or less often than the physics ticks. So we could be adding forces in physics that'll get ignored until the next physics tick, like they won't all get added, or we could be doing things that like it'll just mess up. It's just not gonna work. It'll like mostly work and you can test it and it kind of works, and then it'll be inconsistent when you move it between different build targets and different computers and things. So in fixed update, we're going to do a few things to the car. We're going to apply the throttle, apply the steering, and we're going to do something else kind of weird. We're going to limit horizontal movement. I'm gonna circle back on that, but let's start with throttle and steering. So let's make some variables to hold on to the two inputs that we have in our car: the steering wheel, some turned amount, and the gas pedal, pressed or released. And the way our gas pedal works is it's the up-down axis. So when you're pressing down, when you're hitting it, like you can push your gas pedal negative, and that'll be like pushing the brakes. So we don't need a brake variable separate from our throttle. So we'll call a float throttle, and we'll make, oh, my cat is about to vomit. All right, we're back. We cleaning up some hairballs, writing some code, just a regular morning here. We got a float value for our throttle input and a float value for our steering input. And now we are ready to set those, which we're going to do from the car input script. So we'll have two public functions that we can input values for these variables to set them. So we will set our throttle from is throttle really the right word? It's throttle. I mean, it already means nothing to me. Gas, engine power. Set steering, which will take a float for steering. And now we will set our steering value equal to that steering value. And now the little underscore, that's like one of the advantages of this weird unnecessary character comes in. Because if I don't have that, then I need to type this dot. I need to type this as in the class dot steering is equal to the local steering variable. But instead, I will use the underscore syntax for private variables, which is convenient. We want these values to be limited. We don't want to accept improper input. If our values for steering will be between -1 and 1, and our values for the throttle will be between -1 and 1. So if I input a value of 2 up here, I want to prevent that from being allowed. So we're going to do that with a function in the math library that Unity has called clamp, which if you give it a function outside of a certain range, it will chop it off, chop in the number line, and will only give you values, in between two values. And if you go over or under, it just limits them. And that's called the clamp function. So we're going to clamp, and I always forget the order these go in, but I got my little tool tip from JetBrains Rider that says they go first the value that we're given, then a minimum, then a maximum. So we'll take throttle and we'll clamp it between -1 and 1. And we'll take steering and we'll clamp it between -1 and 1. And we know that because we're writing the car input script that this won't be an issue, but follow up, do we? Do we know that? Especially since we perhaps plan on writing AI in an out of scope part of the project that we won't get to. We'll have some other system that is applying input to the throttle and steering. In our car input class, let's get a reference to the car controller, just like the car controller gets a reference to the rigid body. So we'll have a variable of type car controller, and we'll initialize that in awake. So car controller is equal to the car controller input. And then in update, we'll just call car controller dot set throttle to our input dot get axis vertical. Car controller dot set steering. Did I not make that function public? I did not. Public. Set steering input dot get axis horizontal. And it may seem for a function this simple, like these two lines of code could just be in this function. It may seem that it is silly to separate the input script for something so simple, but I do implore you to do this, even in small prototype projects, because very often the next step will be to switch to the new input system. And not just for clean architecture, but just for the workflow of having your car controller problems in one place and your input problems in another place, and separating these two issues out and away from each other. It really does help clean up. It forces us to write kind of nicer code in our controllers. Okay. And we can do things like sanitize these inputs in a really sensible way. All right. Now let's apply the throttle to the engine. So at the end of the day, we are going to be adding a force to our rigid body. So we're going to take a rigid body and we're going to call that good old-fashioned add force function, just like the one we used in the rollerball game. So what is the force that we are adding? We want to add the force in the y-axis of the car. So as I rotate this car, it's local. Whoops. It's local, and I got here change that from global to local. Its local y-axis is always going to be pointed in the direction up, right, from the transform component. So that's the direction that our engine is always pushing the car. It's just its forward direction. So we just need to access the transform's local y-axis. And we can get that very easily. We can get that with a lowercase t transform, the transform component, dot up. The green axis of the transform in world space. So it is the local up direction. If in local space, it would always be equal to 0, 1, 0. And in world space, it'll always be equal to the, whatever direction that green arrow, that up direction is facing. In this case, this will always be a vector that is a magnitude of 1 that is the direction the car is pointing, which is very convenient. So we'll take that and we'll multiply it by our throttle, which will set it between -1 and 1. So when we're not pushing the button, it'll be 0, so we won't have any input. And then now we need to multiply it by some actual engine force. So let's go ahead and make that. Let's make a serialized private float engine power, engine force. Sure. And we're going to get something fun here. I am multiplying a float and a vector 3. So, which is interesting because it will multiply it will do the first multiplication, then it will do the second multiplication. And when you multiply a float by a vector 3, you're going to multiply the x, then the y, then the z, and then this will be a vector 3, and then you'll multiply the x and the y and the z. So we'll be doing like 6 multiplications. But if I put a parentheses around these two, then I'll be doing this first, 1 multiplication, and then this, 3 more, x, y, z, for a total of 4. So I'm getting a little warning here from JetBrains Rider that says the order of multiplication is inefficient, and I should reorder it by adding those parentheses. And now I have saved my computer a couple of clock cycles, and no one will ever notice because the difference is so small. But I'll know. Great. So now we can test our game. Let's set the engine force to some number. And we can go backwards and forwards, and we're getting pretty close to a game. If the car is rotated and I push forward and backwards, I will in fact move in that direction. Excellent. Let's figure out some steering. So for steering, the way it's basically going to work is we're going to calculate some twisting force to apply to the car. And that's going to be equal to our steering times, again, just like before, we're going to need some kind of steering factor. Steer power. There's a word for this. Steer power. That's not it, though. That's what we're going to go with. Engine force, let's call it steering force. And then, at least it'll have some kind of internal consistency. Because these are serialized, I like to have them not have the underscore, and that's how I know which variables are public, which ones are public-ish, only public to Unity, but not public to other code, and which ones are private, just by looking at the variables. Okay, so we have a torque, and we can apply that to our car. And now let's test that. So if we hit play and hit left and right, what's going to happen? We're going to spin. Nope, our steering force is 0. Let's set that to something. Oh, yeah. Well, we've already discovered one error, which is I'm spinning in the wrong direction. When I hold left, I spin right. When I spin right, hold right, I spin left. So we can just boop, slap a negative sign on that. So I'm just to flip it around. And now we're getting closer. So together we basically created the asteroids movement of a game. So the next step is sort of the most important part of a car controller, which is to prevent cars from moving sideways. I can kind of just like drift and spin and float forever. There's like no friction with the ground. So if we think about how a car would normally have friction with the ground, we can come to some incredibly deep understandings about cars, which is that they have more friction in that direction. Let me change this color. Ignore. They have more friction in that direction than they do in the direction the wheels are aligned. Wheels like to go the direction they can spin. They don't like to go sideways. Incredible insight I am providing to you about the behavior of cars. But that's pretty simple. So what we're going to do is we're going to, let's say our car is, just give it an angle here just for example. Let's say our car is moving in this direction. It's moving upwards, but it's facing in this direction. Well, this vector, this up vector, can be calculated by adding two other vectors together. We can add a vector that is the right axis, and we can add a vector that is the, we can add two orthogonal vectors together, and that will get us to the normal vector. I'm drawing this very small. Let me zoom in. Let me just use this over here. Okay, so if our car is forwards and flinging itself, whoa, what happened? flinging itself out at an angle. I'm on a trackball here. You're gonna have to excuse the wiggly line. I can split this vector into two parts, a vector that is in this direction and a vector that is in that direction. And then I can add them together. And when you add vectors, you can think of them as like just tip to tail. Just kind of add them up to get that hypotenuse of the triangle here. And then what we'll do is we'll take the sort of the horizontal part, that's the vector we don't want, and we'll cut it down to be much shorter, a little bit, because we want a little bit of drift, and then we'll put them back together. So we're going to take our vector, we're going to break it into two vectors that are aligned with the car in a way that is useful to us. We're going to shrink one of them and then add them back together, and that's going to sort of move that direction to be more aligned with the center of the car, which is cool. Great. Go there, you get out of here. Okay. And that's going to be limiting our horizontal movement. So I want to get a vector 2 that is my forward velocity. And I want to get a vector 2 that is my right velocity. And then I want to set my velocity equal to my forward velocity plus my right velocity. Here we go. I'm going to take my velocity, I'm going to split it down into just its forward and right components, and then add them back together. So to do that, and it's complaining, the errors are because these are not, I haven't created these vectors yet, but we're getting there. To do that, I'm going to use something called the dot product, which is very fun. The dot product is a value between 0 and 1 of how aligned with each other two vectors are, which is sort of a dumb phrase, but if my vectors are aligned with each other, that's going to be a value of 1. If they're orthogonal, that my dot product is going to be 0. This isn't a math class. This isn't a physics class. So we're just going to type the code and it's going to work. And another separate video, another separate place where we can back up and think about what the dot product of two vectors is, just mathematically, conceptually. This is not the place. This is not the time. You don't need to hear a rushed and improper explanation of it. But sort of an alignment factor of vectors. We're kind of projecting one on the other. So we don't need to actually know about how the math of a dot product works. You know, you're not taking a AP physics class where you probably have to take some dot products. We're just gonna let Unity do it because it has a vector2 dot dot function. And yeah, we'll take our velocity and we will take the dot product with the direction that we are facing, that is forward. This is a value between 0 and 1, sort of a percentage. So if we take transform dot up, the actual vector 2, and multiply it by the percentage of the velocity that is in the up direction, we will be left with sort of the up factor of this other vector. And if they're aligned, then this dot product will be 1, and then it will be up, and then it will be what it is. And if the vector, if you're sliding completely sideways, then this will be 0, and this vector will be 0. And then we'll do the same thing to the right velocity. Transform dot right times vector2 dot dot, the dot product of the velocity and the transform dot right. Sorry, there's like a bug just flew by. Great. And now if we add it back together and set our velocity back to it, hypothetically, we should have done nothing. So let's test that code right now. It should not feel different. Even though we are manually replacing the rigid body's velocity with something else inside a fixed update. We have a velocity, we're doing some stuff to it, and we're setting it directly, but we're setting it back to what it was before. And ignoring the fact that this car controller is still flying wildly out of control, it seems to be working. It seems to be behaving at least the same as it was before, flying wildly out of control. So that's good. So now we can do the real trick of this whole thing, which is to make this right velocity just a percentage of what it was before. So I could multiply it by something like 0.8 or something. But instead, we're going to use a variable for that. So let's make another float. I'm going to call this drift factor. And because this is going to be, it needs to be some value between 0 and 1. If it's larger than 1, we're going to go faster than we were going before. It's going to be messed up. So it needs to be a percentage here. So we're going to use a attribute called range. Oh, we love it. Which in Unity is going to give us a little slider here. And then I'll take my right velocity and I'll multiply it by my drift factor. So when this percentage is at 0, we're going to be back to asteroids movement. And when it's at 1, we're going to be not able to drift. Our cars will be like, wheels will be locked down. But if we set it to something like 0.9 or 0.85, 0.95, something around there usually feels pretty good, then we should be able to drift. And already it feels much better. I'm still wildly spinning. So let's go to the angular drag and set that to some value 2, maybe? I don't remember my testing values from before, but yeah, we're getting pretty close. So as I move sideways, my car sort of stops a bit. I still kind of spin out really easily, but that's fine. Maybe that's the gameplay. Maybe that's on purpose. Nice. Great. So I have my fixed update. I have sort of these 3 sections that I want to do. I want to refactor my code here to pull these out because I'm about to add a bunch more features to limit it so that I can't steer while I'm moving slowly and to make it so I can't go over my max speed, which will be the last features that we add. But it's going to make this whole fixed update get really long and messy. So before that happens, I want to refactor. I want to make a function for my throttle, function for my steering, and function for my limiting horizontal movement. So let's do that. Let's make a private void throttle tick, and then we will put this in here and do that. And then we'll do one for steering. Tick is a suffix that I use when I know that I'm calling a function from an update loop. So that's sort of the way that I like to remember. This is basically an update loop function. Probably need to write actual things here. Great. And I'm going to apply that stop horizontal movement before we start steering, because I bet that matters a little bit, a tiny little amount. So we'll do throttle, we'll stop horizontal, we'll steering. If it doesn't, we can very easily reorder these, which is much easier to do now than it was before. So next, we are going to do some more advantage. We're going to limit ability to steer dependent on our speed, which is going to prevent us from being able to just rotate the car in place. That's not a thing cars tend to do. We need a little bit of momentum in order to steer. So we're going to calculate some percentage of our velocity that we're at, of our max velocity that we want to be at. And then if we are at a certain amount, we'll sort of, what am I saying? So if we think of if max speed is like 10 or something, and we're currently at 5, we think of that value as like 0.5, we could take our steering and multiply it by that value in order to get a, we can steer more and more and more the faster we're going, and less and less when we're going slowly, and when we're not moving at all, our speed will be 0. So that will be the sort of way that we do it. But we're going to scale that max speed down a little bit. So we're going to make a min speed before turning. And we'll set that equal to the sort of magnitude of our velocity times some percentage. Which will be, we'll need to get the magnitude of our velocity. And then multiply it by some percentage, and we'll call this a serialized field, range between 0 and 1, so it'll appear just like the other one. And let's give this a name, the slow no steer vector. There's got to be a better name for that. I'm committing to it. And that is going to be a value that is a sort of a percentage of our current speed. So it's basically just our current speed, but smaller. So the real trick is to then take that and clamp it between 0 and 1. And clamping something between 0 and 1 is so common that there's actually just a clamp O1 function, which is the exact same as clamp 0 and 1. So now it should make a little bit more sense. When we're 0, and our speed goes up a little bit until it hits some percentage of our magnitude, and then we're just like, and then we can just steer at 1, and it's just as good, and it just works. So we'll apply that min speed before turning value, which now I guess isn't really named that well. It's like slow turn factor. I don't know. It makes more sense in my head than it does when I give it bad names. Yeah, so like just think of your speed going up and down, and this value just going up till it hits 1. Okay. So while your speed is small, your turn force will be limited. Let's test that. Let's see if we, while not moving, can turn. I cannot. But if I move, can I turn just a little bit? My speed factor here is 0. Let's make that like 5. Oh, hello, welcome back. There we go. And as I slow down, I can't turn. It's still buggy because we really should be looking at only the amount of our speed that is in the forward direction to determine how much we can spin. If I'm drifting sideways at like max speed, I can turn. But that's a future optimization, is to change this from our magnitude to sort of the magnitude of this vector instead. But I'm not going to bother right now. Cool. Next, let's set some max speed. So, let's put those ranges at the top. Let's go serialized private float max speed. And now I want to know if I am moving faster than this amount, and if I am, I should just like not apply the throttle to my car's movement. But it turns out it feels kind of bad if we just do that. Like if all I do is check if my square magnitude is greater than my square max speed. When you're getting the magnitude of a vector, you have to take a square root, and that's kind of slow. So I don't want to do that. I'm already doing it here, but whatever. So instead of taking the square root, I can just stop before that part of the function and then square the other side of the equation. And then that's much, much, much faster for the computer to do. But this is rigidbody.velocity.magnitude is greater than max speed. This is just a slightly more efficient for a computer to write way of doing that. Right, return. So that will end this function, and we'll return exit it before adding the force if we're going over max speed. But we'll still do these other ticks, which is another advantage of sort of separating our physics tick out into these other functions, is we can use this like return escape sequence in order to like change the logic in more complicated ways, which is, I think, super nice. So let's set that to 4, something pretty slow that we know that we're gonna get over. See how that behaves. Oh yeah, I'm definitely pretty limited. But I know from testing and from having made a car controller before that it's a little bit, it just feels a little bit weird. You're like flying forward and you spin sideways, and then your car like doesn't like, it should be moving faster sideways because it's really just the engine force where we're hitting our max speed, and that like we can feel that. So instead of doing it this way, maybe we want to leave that code in. I don't know, whatever. I could slightly higher, you know, set some like hard limit. But instead of doing it this way, we will get a we'll use that dot product again to get the forward amount of our, but this time we're going to do it kind of backwards. We get the forward amount of our, the velocity amount of our forward direction. Wow, I said that poorly. And then we'll check if that value is greater than our max speed or not. So it'll be just this code here, but instead of that, it's not a percentage because it's not between 0 and 1. It's going to be the forward velocity factor. And that's already turned into a float, and we don't need to do that. Let me double check my notes. Great. So that will limit our max speed. But we'll do one more thing, is we'll only do this if we're pushing the throttle, like if we're pushing the gas. We'll just like stop pushing the gas. And that way we don't, if we're trying to go backwards and we're over our max speed and we're trying to hit the brakes, it can still hit the brakes. It won't like end it there and leave us at our max speed. So we'll just check if our throttle, if we have any positive input on the throttle. If we are trying to move forward more, but we're at our max speed, then we can stop ourselves in this way. But what's convenient is we can also use this to prevent ourselves from going, you know, we could go faster than our max speed backwards still is a bug. So we need to check if our factor is less than our negative max speed and our throttle is less than 0. Right? So if our forward velocity is lower than our max speed in the opposite direction, which would be a negative number, and we are trying to move backwards even more. But let's do another little fun thing here. One private float backwards max speed percentage, and we'll set this times that. And then, because like cars don't go backwards as fast as they go forwards. You know, I don't think, usually. But now we can control that. So our backwards max speed percentage will be this percentage of our max speed. So if that is like 0.8, our backwards max speed will be like 3 or whatever. So I'm gonna set that around half. Is that good? Is that bad? How do cars work? I feel like that's pretty fast for going backwards. It's so slow, but it is slower. Set that to a faster value. Okay, we got a really floaty max speed car movement here. Maybe my drift, you know, we just gotta add more drag when we're not pushing the throttle button. Let's do that. Let's change the car's drag value. So like if we just set the drag to something, you know, it's gonna be standard normal friction with the ground. But I want to do a trick where if I'm letting go of the arrow keys, you know, there's like, yeah, oh, we can't move very fast. If I'm not pressing the arrow keys on my keyboard, then my car should sort of have more friction than when I am pushing the gas button, right? It's sort of like a passive braking. But if I am pushing input, you know, then I don't want to be doing that drag stuff. The reason I'm acting so hesitant and so annoyed right now is because I kind of want to use this feature for like if we go on road versus on grass. I want to just change the drag of the car, and having this code here we'll complicate that a bit. But I don't think we're going to get to that feature anyway, so I think it's fine. That too should be a variable we can edit in all of our settings. So I should slow down. This is separate than spinning. And it still feels kind of bad. So I did some research by looking at like 8,000 car controller things, like people's code on GitHub and on YouTube and everything. I looked at like a bunch of them, and I sort of like took all of the standard techniques and kind of made my own simple version here, which is where these techniques are coming from. I did not invent everything here from scratch, although I have made a car controller before, and I did basically do this. It's basically how it works. And one technique that I saw that isn't in my notes, but I will sort of demonstrate, is to adjust our drag by pushing it towards some value a little bit over time. So when you let go, it doesn't immediately kick your drag on. It sort of slides it up over time using a lerp. I don't really want to explain the lerp code or get into that. So I sort of cut it from my project. But now I'm like playing, I'm like feeling it, and I'm like, oh, maybe I do need that, But you can see the drag here. Slide. Oh, it goes really slowly. That's no good. Let's make that faster times 5. Okay, we should make this, drag target float, but I don't really want to do drag. Because I think I'd have to refactor it later anyway if we want to do grass, giving your car more drag, like terrains. Oh, but it does feel better. Okay. I'll leave that there as is, and we'll call it fine. Let's move on to our next task. So that car controller, we're calling that done. I'm not touching another line of code on this. Let's bring in some art assets. And using the Unity 2D tile map system, we'll do a camera follow after. This is actually fun. So look at this blue background. That sucks. Let's add a tile map. So as a game object in my hierarchy, let's right click and make a 2D tile map, and let's make a rectangular tile map because all of our tiles we got from Kenny are square. So we'll do that. And now you can see I have a nice grid here that's changed. And I have a tile map renderer component and a tile map component. And those are children game objects of a grid component, where I could change the size of my grid, which I don't want to do. Because we already changed our sprite import settings so that everything will be nice and exactly one. Great. So next, I need a new window that Unity has under the 2D menu, which is the tile palette. And I like to leave mine over here to the side. And the tile palette is it is a window here that lets us grab tiles and paint them onto our scene. But the way the tile map's set up is a little bit not intuitive. We sort of have the palette. I put myself in the worst situation for like writing. It's a trackball. And the palette is made up of tile assets, and each tile asset is going to reference a sprite. Oh my gosh, we can do this. Surely there's a better way. And all of this is assets. And then in the scene, we have the actual tile map component, and the tile map component is going to be told sort of what tile assets are going to be at what position on the grid. I'm not drawing this out anymore. Let me clear that. That must have been excruciating to watch. So we need to make a tile map asset. We need to make tile assets and tell them to connect to our sprites. So I'm going to make a new folder, and I'm going to call it tiles. Let's call it tiles. And then in the tile map, I'm going to click this create new palette button, and I'll call this Kenny tiles. Because you can have like sort of different collections of tiles. You can switch between, you know, your mountain level, your lava level, your ice kingdom level. And in the tiles folder, we'll go ahead and just choose that folder, and that'll make it right here. So interestingly, this is a .prefab file, which is very strange. But, you know, we just don't look behind the curtain and it's all good. So now I have my text in the tile palette. I'm using this tile. I need to add some tile assets to the tile palette. I don't have any tile assets. I could make one by creating a tile. Or are you under 2D? Tile palette, no, tiles, tile. There's a bunch that are sort of have different more advanced like code features built into the tiles. Something I've done in the past is build like a pathfinding system into my tile map. So I just paint and then just pathfinding works. It's amazing. You can have tiles that are like road networks that will just automatically sort of change their sprite to look like they're connected to the nearby ones. So you just paint really fast, really easily. Making a tile ourselves is sort of annoying. So instead, we're going to drag a image from our Kenny folder here. We'll go to our tiles, our dirt road, and we'll drag, I don't know, maybe all of them into our tile asset. And then this is going to ask me for a folder to save all of these tile assets. So we want to be careful we don't choose a bad folder. Let's go to tiles, let's call it dirt road, and let's dump them all in this folder. And it's going to make a bunch of assets, one for every single sprite. That is going to be the most basic version of a tile, which is just rendering the sprite, not changing its sprite or being part of any, you know, physics system or anything like that. And now we have the tiles that we can paint with. I would really want to spend time like moving them around to be like easier to edit. And you can like box select and like paint in boxes. But we're not going to get to that part because we're just making a little quick thing. So let me just grab this brush and paint it here and that one and paint it over here. And that one. I probably should not have added all of them. I should have just added Right. Okay. So there's our tile map. And now we could paint a whole level. We could do a whole thing. We can go to our main camera and change the background color to green. And we're getting pretty close. Where's our car? It's behind the tile map. That is no good. So our tile map has a tile map renderer, which renders all the sprites. They have an order in layer. And our car has a sprite renderer. They're both at the same order. So they don't know what to do. So we want to set our car to be, you know, 10 to be higher up. And I want to leave some room for like other things I might drive over, like collectibles or pickups. And meanwhile, I'm going to set this to like -20. I'm like going to really separate it. So there we go. That's our tile map. We're basically done. That's as much as I'm going to do. You don't want to see me painting a tile map. You can spend as much time as you want drawing out a whole level. We'll talk about how to do collisions later. But I mean, if we just add colliders, everything will work. But a tile map collider, then a second layer to the, you know, a second tile map with a different layer. And this one has a tile map collider and a composite collider, and it's used by composite, and then it creates a nice shape, and it averages them all together with the composite collider doing some optimization, and then we should be able to go to the rigid body and change it to static. It made that when it made the composite collider. Let's go. Bonk. So then we could have obstacles on our course that we can't hit. We would call this like solid tiles, and we call this one road tiles, and we have a background objects tiles, and on the background object tiles, we do the same setup, but we make it a trigger instead of being solid, and then We would check if we're overlapping it and change the drag and physics settings of the car. Oh my gosh, look at all that. Delete, goodbye. Not in scope. We don't have time. That's the next step that we won't get to in these videos. Okay, let's do a camera follow because I feel like that is important. Camera follow scripts. How fun is that? It's not. Let's not do it. Let's use Cinemachine to do it for us. Window, Package Manager. Let's search for the Unity registry for Cinema. And then the ma in machine gives us Cinemachine. And let's install that. Cinemachine is great. We're going to add it to our project and use it instead of doing any of this complicated camera stuff ourselves. We love that. Thank you, Unity, for being delivering on your promises of making game development easier. Okay, so in Cinemachine, we're gonna go to Game Object. We have a new Cinemachine menu we did not have before, and we're gonna add, we have a bunch of camera options. We're gonna add a 2D camera. And we'll call this Car Follow Cam. And the Car Follow Cam has a Cinemachine virtual camera component. And all that this component does is basically it's an empty transform that just has these rules that tell it where to point. The camera, your main camera, is still your camera. Your rendering settings, that background color, that's still the camera that's rendering the game. It has a Cinemachine brain component, and the Cinemachine brain is going to decide which camera to move this camera to. So it can blend between them and it can average the position and slide across them and do fancy transitions between cameras and dolly tracks and things. And it can do all sorts of fun stuff. We only have one camera in the scene, so it's going to choose to follow that one. And we're going to tell it to follow the camera, Cinemachine virtual camera. We're going to tell it to follow the car. And that should be enough without writing a single line of code to have the car work. And it does. We have a camera follow script. And it's a little wonky. It's like a little so we could go into the body and we could, change all these settings, and we could change the look ahead time and smoothing, and we could Google it. What an unsatisfying thing to say in a video where you're learning how to make a video game. Yes, I know, but this is a programming video, and we're moving on to the next part of the video where we're going to make some car checkpoints and the finish line, and we're going to make it all work. And this was just setting up our prototype car controller. So I will see you in that part 2. Before you get there, take a pause, play with these settings, see if you can make something cool. Play with your physics settings, play with the offset your car is from the parent. Play with, fiddle with it and play with it and make it feel better than it feels now. I'm going to skip that part because I'm the developer and that sounds like a designer problem to me. All right, see you in part 2.